It was a dark and stormy night, and the kids were all sleeping soundly in their beds, when all of a sudden... Hey dudes, you might as well take a seat and listen to Mr. Thresher's Campfire Tales.
Hey dudes, Mr. Thresher here. Today, in Chapter 1, I'm going to teach you something that is kind of scary to a lot of you, and that's why this is Chapter 1 of our scary Campfire Tales. It's how to draw a Bohr model of an atom, and it's a lot easier than you would think. Periodic table we learned last week set up group families up and down. There's 18 of those, and then across you've got the periods. There's 7 of those, and in a minute you'll understand what those numbers can help you determine when you're drawing an atom. I chose potassium today. Pretty simple to start with. Potassium, capital K, is the symbol of it. And you'll notice, just like we talked about last week, there's 2 numbers in the element symbol box. The most massive number is the atomic mass, or the mass number, and the smaller number is the atomic number. And I taught you that the smaller number is the number of protons. So we have 19 protons. And if we have 19 protons, remember the class PE goes together, so we have 19 electrons. And in order to find the neutrons, all you do is subtract the 2 numbers, like I said. So 39 minus 19 gives you 20 neutrons. So we're all caught up. Now let's draw. First thing you've got to know is what goes on the very inside of an atom, and that's the nucleus. So I'm going to draw a nucleus, just a little nucleus circle here. And inside the nucleus of an atom, you've got protons and you've got neutrons. So I'm going to put P equals 19 protons, and I'm going to put N equals 20 neutrons. Pretty simple so far. Now, what I'm going to do is I've got to figure out how many energy circles I need to draw around the nucleus of an atom, because the energy circles are where you find the electrons. It's really easy to look at the periodic table and know immediately how many energy circles you need around the nucleus. Since potassium is right here in period 4, that means it has 4 energy circles. So I'm going to draw 4 energy circles. 1, 2, 3, 4. All right. So I could look at this not even knowing what it is, and I could count the energy circles and know whatever this is, it's in period 4 because it has 4 energy circles. Now let's put the electrons. The electrons, if you remember, on each level of the electron cloud, there's only a certain number that you have to memorize of electrons that can go on each of the levels. So if we first start with the very first level closest to the nucleus, and you can only have 2 electrons there, that's it, total of 2. Well, we've got 19 electrons, so I'm going to put 2 on the first level. Once that level is filled, it spills over into the next level, and I can only have 8 in the next level. So I'm going to put 1, 2, 3, 4, 5, 6, 7, 8. So now I've got 2 in the first, 8 in the second, that's a total of 10. So I need 9 more electrons. The third level can only hold 8, so I'm going to put 8 in the third level. 7, 8. So first level 2, next level 8, that's 10, next level 8 more, that's 18. So I need 1 more electron, and that's what's going to be in the very outside. There's something interesting about the very outside electrons. These are the ones that are involved in the bonding with other atoms. And so these electrons in the very outside ring are special, and we call them valence electrons. They're involved with the bonding. And so an easy way to check yourself, and using the periodic table, this is shocking how easy this is. If you've got 1 valence electron, that helps you find out what group family that it's in. 1 valence electron means it's in group family 1, right there. So if you didn't know the name of this, you could look at this and you could tell what element it was talking about. Even if the protons and the neutrons in this inside were not even listed for you, you could still tell what this element is called, because count the energy rings, 1, 2, 3, 4, that's period 4. Valence electrons, group family 1, so period 4, group family 1, bam, potassium. Girls and boys, making all that noise. 'cause they found new toys. Well, we can't salute you 'cause you can't find a flag. That don't suit ya, that's a drag. School's out for summer. School's out forever. School's out for summer. Is this? It's pretty sharp. It's very black in color, and it came from a volcano. It's called obsidian, volcanic glass. Next up, what is this? It looks like a brain to me, but obviously it's not. It's a piece of coral that you would find in the ocean. Brain coral. Next up, what is this? Catch a guess? This is a cheeseburger from McDonald's. But what's interesting about this is I bought this cheeseburger 5 years ago, and I've sat it in my cabinet to see what would happen after 5 years. The bun looks exactly the same, but it's hard as a rock. Here's the meat, looks pretty similar. And so, hey, there's a 5-year-old McDonald's cheeseburger. Next up, what are these? I wonder what these are. These, what you'll get if you eat too many McDonald's cheeseburgers. Each of these is 1 pound of body fat inside your body and what it looks like. What is this? This is a model of your arteries. Over here is a clear artery. Over here is a clogged artery. You get clogged arteries from eating too many McDonald's cheeseburgers. And the red represents the blood cells that are flowing through the arteries. I'm going to turn this over and I want you to watch the blood cells, how they flow. They flow nice and uniform all the way up. But if you'll notice here in the clogged artery, they get stuck throughout. And this, getting stuck and breaking off and getting clogged arteries is what can cause you to have a stroke. School's out for summer. School's out forever. School's out for summer.